we planned for today, and let's try it out and then see. So first of all, data type. Okay, when means if you know the answer, please raise your hands. I don't want the group answers, so raise your hand so that I can call and then I ask. So what is data type? Or what are the data types in Java? Okay, go ahead, Prantha. What is data type?
Sir, I can answer what are the data types. Can I?
What is my question?
What is the data types and what are the data types?
I want what is data type. Once we answer what is a data type, then I want to go for what are the data types.
Okay, sir.
Anish.
Yes, data type is nothing but it's a nature of data or is a category of data. We're doing that.
Okay, Vishnupriya.
Type of the data, in simple words, like whether it is int or float, type of the data, like when we are trying to initialize any variable, like the variable type, it's type of the data.
Absolutely. It is a very simple words to explain about this one. So that's the name itself, it is saying it. So now, for an example, let me take this. I have been defined a particular variable A. Okay. Now this is called data. What type of data is this? So now, based upon the value which we wanted to store in this particular variable, so those are the things which it is called as a data type. I know it is a little bit difficult to define or give the definition for this one, but you would be understanding something, right? See now, I'll define that particular variables. Now, what type of data I should store into this particular variables? This is called data type. Type of the data which I wanted to store in the variable. Simple definition only, right? Type of the data which I wanted to store in this particular variable. So now, first of all, what we have been discussed about variables. Now we wanted to discuss about data types. So variables which it can varies that particular values and dynamically it can change. So these are called as a variables. Now, what type of data you wanted to store it into the variables? This is called data types. The simpler definitions. You don't see that definitions here, but that is where you need to understand. That is what, right? What are the different type of data which I can store into this variable is called the data type. Now, what are the different data types we have? Ranjita, what are the different data types?
Primitive data types and non-primitive data types. In primitive data types,
Go ahead.
in primitive data types, we can see char, byte, short, int, long, float, and double. When it's come to non-primitive, it's array, classes, and the interface.
Cool. So now, if you see here, you can see that there are two data types it has been divided. So one is primitive data type and another one is non-primitive data types. Always you need to remember this. The data types are classified into primitive and non-primitive data types. Now, what are the non-primitive data types we have? So now here you can see that byte, short, int, long, float, double, boolean, char. 1, 2, 3, 4, 5, 6, 7, 8. 8 were part of primitive data types. 3 were part of non-primitive data types. Now, let's see what are these particular data types. Now, how we can know? Okay, first of all, you need to know the definition of this one, right? What is primitive data types and what is non-primitive data types? Anyone knows the answer? What is primitive or not? What is non-primitive?
Like primitive data types means in the Java, within the Java, there exists like when they are developing the Java, they're given some keywords. So those are primitive data types. Non-primitive data types means these are user-defined data types. Like a user can define a data type and can work with that.
Excellent answer, Shishir. So you need to understand. So because many of the people will not understand this particular definition. If you read this particular statement, you will be understanding this. See, a primitive data type specifies this. So that means this is the primitive data type, right? This specifies the size and the type of the variable values, and it have no additional methods. Very simple. Yesterday, I think before last week, I think Durga has asked one question. Hey, why this is start with the capital letter, and why these things are starts with the small letters? Did you think about it? So now all non-primitive data types are starting with the capital letters. Why? Because as soon as the Java started, at that point of time, they have been given with this one directly. Later on, this is added. And if you see here, now these are the defined with the classes. So always you remember, class name starts with capital letter. Strings, arrays, classes. So these all starts with this one. And you can add the methods for this. Now you will see the string methods, you see it, right? What are the string methods you worked on? Length, to uppercase, to lowercase, trim, equals to, compare to, substring, in string. You have a lot of methods on this. For arrays also you have the same methods. When you go for arrays, you'll understand that. But did you see any particular methods for byte, short, int, long, float? No. That is what it was saying that. And these are keywords. See, always you remember keywords are small in nature. Do you remember public, void, static, domain? So these all things are in small letters because those are keywords. And these are the classes where you can generate the methods for that. So that is what the basic difference between a primitive data type and a non-primitive data type. See, what are data types you can explain. So I have primitive data type, non-primitive. But what is primitive data type and non-primitive data type? You should be able to explain. So that is what we are explaining here. So primitive data types are, it will have a specific size. Now you see it, a byte have this size. And it can have a variable type. So now byte, you will be defining it, right? So you'll be giving in the exercise, say this is byte, or this is the float. You'll be giving it, right? That particular specific type of variable values means based upon this particular variable values will be having it. And then it have no additional methods. You seen it, right? There is no additional methods for that. So this is called, yes, just give me 1 second. Okay, sorry. So now this is called a primitive data type. Now opposite to this statement means where this particular data type having the particular methods and everything. So then that is called as non-primitive data types, and it can define with the own methods, and you can define own. So that is where those things are called non-primitive data types. So now under primitive data types, we have bytes, short, int, long, float, double, boolean, carry. Now this is what the size. Now for an example, why? What is the size meant? Example, now you went and you take a selfie. Now for example, now you have 100 KB. Okay. Now you taken 10 pictures. Now 100 KB will reduce to 90 KB. So considering 1 KB for one pic. you take in 100 bits, the size will be filled. Means everything which you wanted to store, it occupies space. Agreed? Everything which you wanted to store, everything or anything you wanted to store, then this occupies space, right? Now anything, so you wanted to keep a TV on the wall, or you wanted to keep something in our kitchen, or you wanted to keep something in our gym, so it will occupy space, right? So now the same way, when you wanted to store these particular variables, means this particular data types into these particular variables, it should have the storage. See, for example, a cot. So how much cot will occupy? 6 into 7, 6.2 into 7, 7 feet, 6.2 feet into 7 feet. And if I wanted to, for sofa, I use 8 feet into 3 feet. Recliners. So now every object will have different shape and size. According to that particular size, it will occupy the space. Size matters, right? So now based upon the size, it occupies the space. Size equal to space. How much size it will be? It occupies that much of space. Now here, these are the different data types. For each and different data type, it will occupy with a different size. Now let's see. First of all, what is a byte? So nowadays, what it happens is, byte short we will not use at all. You can see it. These 4 things belongs to one particular category. These 2 belongs to one category, and these are different categories. Okay, these 4 are one category. These 2 are one category, and these are 2 different categories. Why is this 4 are one category? Means these are whole numbers. Simple. What is a whole number? Whole numbers. So now I'm telling you, right? So 3rd class maths is really important here. So whole numbers, it is now whatever the number, without having it. Simple definitions I'll give it. So no need to confuse too much. Without having any particular decimal pointers, if you have a particular complete number, so then that is called a whole number. Now the range of this particular byte, means what the byte can store is 127, means minus 128 to 127. This means it starts from here, minus 128, minus 127, minus 126, minus 2, minus 1, 0, 1, 2, 3, 4, 126, 127. So this is a range of numbers which you wanted to store. You can store it into a byte. And 1 byte equal to 8 bits. So bit equal to, it is nothing but ones and zeros. Okay, it's a smallest component. So now you can say that 1 byte of space is required, and the whole number is 128 to 127. Hey, do I need to remember all these things? At least you need to remember these sizes. Why to remember these sizes? I'll let you know, because when you go for an object, the creation sizes, definitely I'll ask you these questions there. See, when I'm asking the questions, only very few people has been given me the right answers in the space. This matters a lot when you're doing the execution. When we creating an object, when we're talking about the constructors, you will know what is the importance of this. So now we use 1 byte, which it stores 128 to 127, and we use short. Short is nothing but it will occupy 2 bytes, and the range of this one is minus 32,000 to plus 32,000 change. So you can remember that 768, it is not really required. At least you need to remember 32,000 to 32,000, minus 32,000 to 32,000 change. And the most, see now, very frequently we will not use these 2, but we will use this 2 very frequently. At least integer. So now you can see it, right? 3, 3, 3, 9. So what you can do is minus 2, 9 digits to plus 2, 9 digits. So that's a range of an integer. Very simple to, so that this is not possible for anyone to remember for a longer time. Even if you remember for once, so you'll be thinking that for tomorrow you'll be not saying this. So at least minus 2, 9 digits to plus 2, 9 digits. That's a range of an integer. Minus 32,000 to plus 32,000 change. It is what the short and a byte. So now you need to remember this one as BISL. BISL. So that you can remember the hierarchy. So bis only 1 byte, short for 2 bytes, int for 4 bytes, long for 8 bytes. So that always you remember this have a bigger capacity when compared to integer and long. So now both are whole numbers only, right? Both are whole numbers only. Now what is the range? You can see it here. Minus 9. How many digits? I think it's 15. 1, 2, 3, 4, 5, 6. 6 3 is 18. 18 digits. Minus 9, 18 digits to plus 9, 8 digits. So this is the range of the long. So especially when you, why I said 16 digits, because when we are giving a credit card number, so you wanted to store a credit card number which have the 16-digit card number, right? At that point of time, we use long. But 95% we use int. And then very rare case, if you're working for a fintech company, there we will be using this one in numbers. Okay, BISL. So BSIL. So now 1, 2, 4, 8. So always remember int. So these two things you shouldn't forget. Int and float will have 4 bytes and 4 bytes. And long will have 8 bytes. Double will have 8 bytes. Long double and this one. So this is FD. You have fixed deposit, right? All integers. So float values. 8 bytes, 4 bytes, and 8 bytes. Now, what is float and what is double S? Float is nothing but if you have the fractional point or decimal points, then this is called float. Means apart from the whole number, we wanted to store fractional numbers also, right? If the particular fractional decimal points is 6 to 7, then it will be stored as a float. If it is more than 7, then you will be going for double. So this is storing a bigger number. So that's the reason it takes a bigger space. This is also storing a bigger number. That's the reason it takes the bigger space. Float, double. This is called fractional pointers, or you can have decimal points. Means after point, if you have number of digits, so this is what called as a decimal point. This is a decimal point, right? Now, how many numbers are there? So those are the numbers which is talking about it. If you have 6 to 7, then it is the float. More than that, this is called 15 decimals. And Boolean values. So Boolean values. So I wanted to see here in the Boolean, true, false. Means Boolean, only two. So either it should be true or false. If you wanted to store that, because most of your logical operators depends upon this true or false. And believe me, if you really learn variables, data types, operators, strings, math, you can write 60% of logics. Any logic you wanted, you can write it. And if you learn this particular set of loops and everything, 90% of all logics you can write in Java. This is the base thing which you need to learn. And once you understand this one, this will be useful in any program language. So any programming language. Okay. Now, char. Character will store a single character. Only a single character. And every character will have an ASCII values. So now if you wanted to see what is this particular ASCII values is,
American Standard Code for Information Interchange.
absolutely. So because if you wanted to change the information, so this is what we can be using it. So now if you see here, This is decimal, hexa, octa. So now here everything will have a different name. So now you can see it, right? For A, B, C, D, E, F, capital letter A, B, C, D, Fs, for special characters, and for small characters. This is the octa number. So now octa for small a 141, octa for capital A 101, and small b 62 hexa, decimal 98. Hey, why to convert this all? I can write capital A, capital small b, right? Why I should have this particular exchange values? Will not understand here, but when you go for particular algorithms, when you're writing for this particular algorithms for security purposes, and these all things, these particular things will be converted. So where we use the ASCII values and ASCII tables, that's a different topic altogether. But you need to understand that. So these are the ASCII. ASCII means the definition, the standard form for this one is. So this is American Standard Code for Information Interchange. So this is called the ASCII. And these are the values to convert. Means what is capital A, capital B, small a, small b. So these are the ASCII values. It can be converted into 3 different formats: octa, hexa, deci. Or so now into this particular values it can be done. So now you see it, capital letter, same A, it is 101. Small letter, it is 141. And these are all special characters. So you have to be very much cautious in this particular ASCII table. And we don't use this one. So because we will not write algorithms, or we will be not works in the kernel level. So when you're doing it, so at that point of time, we'll be using this one. So char, very rarely we will be, not very rare. I didn't use it at all. So probably we'd use int and float boolean. So these are the more frequently used. In rare scenarios, long and double. Okay. So now this is where the exercises which you can see on this one. So I think you have been done multiple exercises. So on the whole numbers, on this particular char, and then this thing. So hope you will be very clear. So this is integer, this is float. I told you, right? So this is what our camel notation. It should start with the, not this is one. So the notation which we have been discussed, right? int, capital letter, and then followed with the small letters. So that is what the Hungarian notation you need to follow, because here we didn't add it the type of this one. Okay, so now let's go for the numbers. So here it was giving, so what it stores. So now according to this particular, so whatever the explanation we have been discussed about the numbers, whole integer numbers, floating point, and the bytes, what is a byte. So it was getting that from the range. Okay, so now why, okay, what is the purpose? If I have this one, what is the purpose? Why I should use this and this? See, now you have a bigger sofa. You wanted to keep into that room, what you do, you keep the smaller sofa because it occupies less space. So how much it is required, you will give it. Even you allocated a big space for a small sofa, then that is waste, right? So for example, now this is a big hall. Just if I keep one sofa here, you have this free space. But now what we do, so we will be keeping whichever it is not really used, we have been added this, it's a waste. So just a big table here. It is no point of using it, right? So if I only for saving the spaces, we will be having it. Because if I have only need to store a smaller number, I don't need define it as integer. But is it a problem? There is no problem, but it consumes 4 bytes. See, if I wanted to store 100, I can store with a byte. Why we need to use 4 bytes? It's waste of space, right? So that's a fine tuning of your programs. Now, how it matter to me? So it may not see that particular difference for you now, but when you do the executions, at that point of time, memory out of bound. So we'll be getting the space out of, means that particular size would be occupied more. So then when means these are the objects, so that's other concepts which we talked about later previously also, right? Garbage collectors and these things will come into the picture. So there we can see it. So integer occupies 4 bytes, byte and then short occupies less space. So that's the reason it is recommended to use byte, but majority of the people directly go for integer rather than using the short and byte. So now you can see it, right? Minus 32 to plus 32, and integer minus 2 to plus 2, 9 digits. So they have been used long, float, and long. So you'll be having minus 18 digits to plus 18 digits, floating point. So you'll be having it. So when you have a decimals, so here they have been given it, right? A floating point whenever you need a number with a decimal, so 9.99. Anything which it is from 6 to 7 range, then we'll be giving this one. And always you remember that the float and double data types can be stored in a fractional. Note that you should use the end of value f or float for d for double. None of the people asked me this. I thought someone will be asking me. See, this is a representation which you want to give it, because why we wanted to represent this one as, because here you have been mentioned it float, right? Why we need to give it? Because we are not mentioning it for integer, but for integer we will not mention, but for long we'll be mentioning with L. Why I need to do this? Because that is a syntax, boss. Why I need to go right side? Means why I'll have it free left? That is the traffic rule in India. In Java, if you wanted to use any particular long, you need to keep this capital L. And when you're using float, you will be using it small f. When you're using double, use small d. What it will happen if I not add this? It will not have anything. You
We
can
get an
see.
error, sir.
So it depends upon the version of Java. For few versions of Java, it will not throw error, and few versions of Java, it will throw the error. Okay. So always you need to remember. And if you wanted to store the power numbers, so scientific numbers, so that also you can store. So you know, right, the scientific numbers. So this would be with the capital E's and the small e's and all. See, these we will not use it. Why? Because mostly we will be not go for that particular algorithms or anything. So that's the reason this is not really useful for us. Now you see it, right? These are the scientific numbers: iota, jeta, exa, peta, tera, giga, mega, kilo, hecto, deca, base, deci, centi, milli, micro, nano, pico, femto, atto, japto, yokoto. So if you see here, now these are the multiple notations. Now 10 to the power of 24. So then it is called iota, zeta, 10 to the power of 21. So now this many zeros. So to remember this many zeros, it is really not possible, right? So then it is called as zeta. Okay. So this is how this will be represented. Now you can see that E. So now these are the capital letters and small letters where we'll be using on it. Okay. So this is would be for the scientific calculator. And we will not even get into too much of these things. If you wanted to store those things, so now this is how we will be storing that one. But never try to get into these things. It will confuse you. Just for your explanation, I was giving all this. Next one, booleans. So now we'll have, see, very means always your logic means when you go for a programming logic. So always you need to, because when you're comparing something, the comparisons, those all things will be depends upon this particular any logical operations. It depends upon the true or false. So now this data type will have only two things: 0, 1, true, false. So it is like on, off, yes, no. These all same things. It will be coming in, right? So now you will be defining it with a boolean. So all things are small, and the variable name and the value. So this is how boolean values will be given it, and any conditionals or any particular comparisons will be happening. So we will be letting you know what it means based upon this condition. Then you can do. For example, if he scores greater than 75%, then this is called distinction. If he scores greater than or equal to 60%, then it is called first class. So that is how you give the conditions, right? So when you're doing that particular conditional testing, so there all logics will be coming on these particular booleans. This is really very important. You have to be cautious. And operator and nor operator. So anyways, when we go for these particular operators, we'll discuss in detail. Okay, so we got this particular boolean. I'm not spending too much of time because you already implemented and you understood it. Clear. Now this is for char. So now in the char, see if I wanted to store a single character. So sometimes we need to store a single character. At that time, we'll be having it with this one. So now probably you'll be defining a single character. So that which we can see on this one. And all see now, either you can store the single character or you can store the ASCII value of this one. ASCII values we have been seen it, right? So the ASCII values of this one you can store into this particular things. So anyways, we will not use this particular char too much, but that's the reason which I wanted to store. See now 65, 66, 67. Now go for this one. You can see that 65, 66, 67, A, B, C. That is the reason it print that A, B, C. You see it, A, B, C. You got it? So either you can store directed char values or you can store the ASCII values also. Okay, you can see the table references for this. Now, char would be in single quotes. Now, string. Okay, so this is string, and we wanted to store this particular value, right? So, string, actually speaking, a technical word, this is an object, but here we'll be calling this as a variable. Why I call this as an object? When you go for in the strings methods, you have been seen it, string pool, string comparison, string buffer. If you go there, you'll understand why I call this one as this. But as of now, you don't get confused. So you'll be having double quotes. Okay. Now, what is the difference between a char and a string is char can store only one character. String can store multiple values. So if you keep the double quotes, then this will treat as a string. Now here you give decimals, integers, booleans, whatever you give it. So those all things are strings only. Okay. Any questions still here?
Yes, sir. From one question from my side, sir. Sir,
Guys, just give me
can we
1 second. 1 second. I just need to take this call. Just hold on for a second. Go ahead.
Can we use 0 and 1s in the sir as a boolean in the Java, sir? Means 0 means false and 1 means true in the Java.
Why you use for zeros and ones? You have true and false. Right? What is the purpose of using there? See, Boolean means it gives you the value of true or false. That's it, right? Why can't means why I wanted to store 0, 1s and everything. So if you're storing 0, 1, now that would be like a cat, right?
Okay.
One character you wanted to store there. It will take that particular ASCII value and then it will go there. You see it here. You see it 0, 1. This will go for the char, not for the Boolean.
Means 0 and 1s is not supporting in the boolean, means in the Java.
Why you wanted to have that? What is the purpose? Okay, it will not do. It will not support. See, you should have some logical thinking, Anish. See, what is the purpose? Now we will be using. If you wanted to store 0, 1, 2, 3, 4, 5, 6, 7, 8, you have integer to store. You wanted logic is true or false. Then you'll use true or false. But what is the condition where we use 0, 1? We will never use it, right? Any other questions?
Sir, I have a question in this data types. there is one concept for lower range calculation. Uh, can can you just explain a little more on that, because I had a problem understanding it. Is it only, does it only work for bit, like byte, or it works for int as well?
You have any implementation you have done to get the clarity there? I didn't understand your
Yeah,
question, Yoga.
yes, sir. Can I share my screen? I
Yes.
can show you what I'm asking for. I'm sharing my screen. Just give me a moment. Can you see my screen, sir?
Yes.
So in this place where I have commented them, this is a lower range calculation.
What do you
Uh,
mean by lower range calculation?
that is how it was framed in the document. But when I tried it, it seems like A and B I have given as byte, and I have given a value 10. And when I try to print it in this line number 28, I get an error because I cannot store it in a 2 bit. I cannot store it in another bit, even though 10 plus 10
Oh,
is
okay.
having a value of,
Let me show you. 29 is printed for you or not?
yes, 29 is printed, sir.
That's enough, right? Why you wanted to do it in 28? See what it is
Sir,
doing.
no. I think, no, sir. I think I should comment this. It doesn't print it directly. I have to do a typecasting. That is my question here. If
Where?
I do it, I'll save and I'll show you. If you can see, so this one, this is after overflow. Yes, sir. So see, if you can see, I have a value here now 20, but I get this value only in case of typecasting, this kind of method. If I do it directly, like byte C is equal to A plus B, which I should be allowed, because 20 is within the range of minus 128 to 127, the value which a byte holds. But still I'm getting this error. If I do this, if I
Okay.
comment this, and
So
if
just
I, yes, if I comment this and if I run this, I will get an error. If you can see a mismatch, it's telling me to convert it into int or do this method, approach for this method. Why should I do that? Because this is kind of typecasting that I'm doing.
see
And
what
I
it
think
was
that,
trying to take is, you read the error message. What it was trying to do is that's a compile time error because a plus b equal to 20 will be an integer. It was by default it was taking as an integer. So now what we are presenting it, you're defining C as a byte, but the output which it is getting as a 20. Now I understand your question, Durga. What is your confusion is, hey, 20 is also a range of 127 to plus 127 to minus 127, right? At that point of
yes,
time, it need to print. I don't need to give explicitly as an byte over here. See now, this is not typecasting. See now, when you're saying the type, what do you mean by typecasting? Typecasting means you're changing from one particular type to another type. Then this is called typecasting. But here you're
okay,
not doing
sir.
that particular typecasting. So this is byte, but you're explicitly once again saying that, but this is byte. We consider this as a byte. So because
No, sir, I'm declaring C, a new variable C, right? I'm declaring byte C, which I have not declared earlier. So
but the
this
Java
is,
compiler is taking this as an integer. I told you, right? By default, now none of the people will use as a byte. So now whatever the a plus b value it is taking, it is considering that as an integer. Now when it is an integer storing in a byte, it is where the compilation error is coming. So that is the reason you need to add this as a byte. I understand your question. So what is your question is, I define this as
then
all bytes, right? Then why I need to get this one as a byte? So by default, it need to be a byte itself. Why I need to give explicitly on this one? I'll see that particular thing and then I'll get back to you on this. We'll take
okay,
this one
sir.
offline.
Okay, sir. Thank you, sir. Thank you, sir.
Any questions? Okay, let me take you through the next. It's already. So now, yeah, let me close this one and then we'll stop it here. Hope you are able to see the screen. So now we have been seeing this one as till string, and here it was saying that special. See, the same thing I have been talked about it, right? So this is technical speaking, this is an object. So don't worry about this one. So we will discuss this particular thing in the later part. Even this guy also said the same thing. Okay, we completed till the characters. Now go for the non-primitive data types. So now what is non-primitive data type? So I'll just stop, I'll complete this one and then I'll stop for today. So then tomorrow I'll be continuing with this particular typecasting, operators and string. Okay, and non-primitive data types is called as a reference types because of the reference to the objects. So probably if you understand what is an object, then it is you can understand what is this references means. Okay, so when I'm explaining about this means there is a very bigger sessions on this particular things on the objects. I'll talk there the object and what is reference. You'll understand that one very clearly there. You just keep this one identified. So the basic differences we'll see it. Primitive data types are predefined from the Java. So which is like a byte, int, char, flow. So these are defined in Java. Non-primitive data types are created by the programs which is not done by Java, except the strings. Means so another means any particular data type which you wanted to define. So those things are developed by later versions and someone has been contributed to Java. Not by default Java has been given, except strings. Strings also given by the Java people, but later versions we got that one. And non-primitive types can be used to call methods to perform certain operations, while primitive types can't. So I told you, right? For non-primitive methods, we'll have methods to perform. Means string methods we have, right? Split, join, these are. Primitive types, they don't have these particular methods at all. Okay, and a primitive type as well means always it should have a value. For non-primitive types, you can be null. Means a string. See, for an example now, what it was trying to say is, so a primitive always it should have certain values. Means for an example now, you are defining it a equal to 100. So now either integer or whatever the things you wanted to do it, right? So you are defining those particular values. You need to assign certain value for this. But non-primitive data types, even without having the value, even if it can be have a null value also, it can be done. So now what is the difference between a zero and null? What is the difference between zero and null?
Zero means the value 0 is assigned and null means no value is assigned.
Absolutely, absolutely. So now when I have been given it as 0, okay, now this is an integer or short byte, whatever the value you wanted to assign, you'll be assigning for this. But now where I have been given it as a equal to null, means nothing, no value is assigned for this a. And for this one, the value of this one is 0. So that is what the difference is between the null and the void. So even in your logical implementations, you'll be doing this one. Okay. And the last difference is it starts with the capital letter and this all starts with the small letters. So that's a basic difference between a primitive and a non-primitive. But yeah, so this is for just for your information and then understanding I have been given on this. So tomorrow we'll be starting with typecasting, operators, and we'll see whether we can come to the strings or not. Now, what is your job for tomorrow is whatever the pending methods from the string, it should be completed by tomorrow at any cost, because this is the 4th day which we are giving it for strings. Next, math, booleans. I'll not give too much of things. Actually, in the math, it is very simple. And even in the booleans also, it is very simple. So string, math, booleans is what you're going to present me for tomorrow. Whatever the exercises here, you can just take that particular exercises and then you can show it. Okay, math,